Okay, and we are go. All right, so welcome again to Math 112. Is there anyone here who wasn't here last time? So several people. Unfortunately, we didn't record the last lecture. It's, I wasn't planning on recording anything, but someone talked me into it. So I'm recording 3 classes this semester. We didn't really talk about much. We just sort of talk about the syllabus and some things you should never do. We never really started the syllabus, but we started with a bunch of warnings. Do you remember things that we should never do? Yeah? What? Yeah, the people who were here last time. You'd have to answer, you weren't even here. Someone was here last time. What were some of the things we should never do, no matter what? Even if someone's holding a gun to our heads. Yeah.
Distributing powers across sums.
Distributing powers across sums. That means if you see something like x plus 2 all squared, and you write x squared plus 2 squared, so that's x squared plus 4, that is wrong. That is incorrect. I have an abundance of markers now. Last time I had to go back for markers. You can't do that, right? Because what you're doing here is you decide to distribute this power across a sum. It's a very common mistake. It's something that you should not do. This is illegal. Once there's a plus or a minus sign, so if you had x minus 2 squared, and you did that, that is also wrong, right? So we know we cannot distribute powers across sums. It does not work. In fact, we actually looked at the general formula. A plus or minus b all squared is equal to a squared plus or minus 2a squared. Right? There are actually 3 terms to this because you have to, it's actually multiplying out. You have to do and FOIL and do all that. Right? So you can't just distribute powers across sums. This also applies to radicals. So if you see something like the square root of x squared plus 4, and you write down this is x plus 2, because what you did was you took the radical of the x squared plus the radical of the 4. That is also wrong, because that is distributing a power across a sum, right? Radicals, remember, we just think of those as fractional powers. So this is really just x to the 4 to the 1/2. You can't just put the half power here and the half power there. It does not work if there's a plus or a minus sign. So you cannot distribute powers across sums. That's something you should never do. What's another thing we should never do? Cancel across sums. So if you see something like 3x plus 1 all over 3, and you do this to get x plus 1, that is also wrong, right? Because you cannot cancel things when there's a plus or minus sign separating. You have to cancel across multiplication or division. So if it was 3 times x plus 1 all over 3, then yes, you can cancel the 3's. Without these parentheses there, you cannot cancel the 3's, right? It's illegal. You cannot cancel across sums.
So how would you solve that?
Oh, if you had like an answer and you had 3x plus 1 all over 3?
Yeah.
Well, one, you could leave it like that. It's fine to leave it like that. It can't really be simplified. Otherwise, what you could do is you could just separate it. You can put each over 3. And then in the first one, you can cancel that, because now there's only a multiplication. Right? And so you can leave that as x plus 1 over 3. Right? But usually either of these would be acceptable. But if you do cancel the 3's and do that, that's wrong. That's illegal. Right? So don't do that. So you can't distribute powers across sums. You cannot cancel across sums, meaning once there's a plus or minus sign. I'm using the general form of the sum. If it's either plus or minus, you can't do it, right? So if I had 3x minus 1 all over 3, I still can't cancel the 3's because there's a minus sign separating terms here. Okay? What else should we not do? Divide by 0, because it's just crazy, right? It's just crazy. Division by 0 doesn't make any mathematical sense. Right? It's meaningless to write that down. It's like you're writing an English paper and then write blah, 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 in the middle of it. It just doesn't make sense. It doesn't make sense for the language. And anything else? Neglecting your brackets. Do not let your brackets get lonely. Use them, right? Use brackets. Right? Usually you'd want to open a bracket after you apply a minus sign. And I gave us example similar to, if I want to take x plus 1 and subtract 2x minus 3, I had to put the x plus 1. The subtract means minus, but once you put a minus sign, you have to open a bracket. Right? Because there's a distributive law that says signs have to distribute. And if you don't put the brackets, you might forget to do it. And I know a lot of people decide to be sloppy and they're like, oh, I know there a bracket should be there. I know you have to distribute the signs, but trust me, I already gave a test to some of the other classes I'm teaching. I'm teaching Calc 2, and people are losing points for this in Calculus 2. Trust me, you will forget that there are brackets there if you're in a test and you're under pressure. Don't forget to put your brackets. Be very careful of your brackets. And as we go along, if I'm using brackets anywhere, I'll emphasize it. Oh, we need brackets here, so pay attention to things like that. So we talked about that. That was pretty much the only math we did last time. So this is lecture 2, but technically it's lecture 1. Because now we're going to finally start what is in our syllabus. And I'll again say, I don't particularly agree with how the syllabus is arranged, but since your online homework is sort of lined up with how the syllabus is arranged, I am going to follow it nonetheless. If you look at your syllabus for a list of topics, the first topic is absolute values, solving absolute value equations. So I'm going to start there. And I'm hoping that the last math class you took will give you enough background to fill in any gaps that you'll have here. Okay. So in your textbook, we're going to begin with section 3.3, absolute value equations. Let me start with notation, so you know what this looks like. It's straight bars, right? So if I write this, this means the absolute value of x. Right? That's how you read absolute value of x, right? These signs here are the absolute value symbols. So whenever you write these two straight bars, you're saying you're taking an absolute value of something. The basic concept is you have something called absolute versus relative. In absolute, we only care about magnitude. Or size, right? Not signs or relative positions. Right? So, in of course relative, we care about relative positions and signs. Right, so absolute just cares about the size of something, how big it is, and necessarily we usually talk about this in terms of positive numbers or non-negative numbers. You know, like 2, we can think of that as an absolute value, it's the size of something. -2, we would not think of as an absolute value because that's talking about a sign, right? And -2 sort of indicates the position according to 0, right? All the numbers that are negative we put to the left of 0, all the numbers that are positive we put to the right of 0, but in absolute value we don't care about its relative position to 0. We don't only care about the size of something, right? So absolute values, they really only care about magnitudes, about size, and so we don't care in particular about negative signs. So here's the definition of the absolute value. When you write absolute value x, this is how you should think about it. If your x is already greater than 0, it will do nothing, right? It gives you the same number, right? If, however, your x is negative, it's less than 0, it will take the negative of it to turn it positive because we don't want negatives, we only want signs, right? So that's sort of how it will work. So, for example, if I say absolute value of 2, what is that?
-2.
It's just 2. Why? Because 2 is already greater than or equal to 0, so it just gives me back the original number. It won't change it, it won't make a difference. If I say absolute value of minus 2, then what is that?
2.
That gives me 2. What does it do? It says if it's negative, take the negative out. So I take the negative of negative 2, and that would give me positive 2. Right? So the absolute value always wants to keep things non-negative. It always wants to keep things positive. You can look at also at the graph. If you're graphing y equals absolute value of x, what happens is, you remember what y equals x look like? What does y equals x look like? Yeah.
Right.
Right, like this, right, going through the line like that. Right, so this is the x, this is the y. Now, the absolute value doesn't like this part, right? Because it's negative. What the absolute value is going to do is going to take the negative of all the numbers here to flip it positive. So the absolute value sign is going to get rid of this part and just take the negative of all those numbers to flip it over the x-axis. So the absolute value function looks like a v, where the lowest point is 0. So that's what the function looks like. So you'll notice here, if I take 2, the absolute value of that would just give me 2. If I take negative 2, the absolute value of that is also 2, right? It will always give me the non-negative number. Right? So that's how absolute values behave. You want to care about size, about magnitude, and you want to keep things non-negative, either 0 or positive, and that's how this thing works. Another graphical example before we move on to some computations. Do you know what x squared minus 1 looks like? Do you know how to graph quadratics, x squared? Did you do that in your last class? These quadratics look like parabolas, right? It's either a cup or an upside down V. This one says you take x squared. Remember y equals x squared just looks like this. Right? That's y equals x squared. But now you shift it down 1. Right? So this graph looks like that. Right? What if I wanted to graph the absolute value of x squared minus 1? How do you think that would change?
From 90.
Where is it going to be up? Flip what?
In the middle.
The whole thing? The bottom part, the part that's on the horizontal, all these points here are negative. What absolute value is going to do is going to take the negative of all those and flip it up. So the graph is going to look like, right? Because it doesn't like this part, right? It's negative, so we flip it up. So that's just giving you an idea graphically of what the absolute value does. Any part that's negative, you flip it to make it positive. You do that by taking the negative of it. Right? So that's one thing we want to keep in mind. Okay, what else did I want to tell you here? Now let's start working out some algebraic equations. So basically, we can take away from this two things. Well, there are a couple more things, but I'll get to that when we get to it. So there are always two cases to consider. If absolute value of x is equal to p, right? These are just numbers or variables, whatever you want to call them. Then there are two cases. Either x is equal to p or minus x is equal to p, right? In the case where the x could be a negative number, the absolute value take the negative of it. So what you do is when you want to solve an absolute value equation, you can always break it up into two separate equations without absolute values, right? And you solve each one to see which one will work for your case. Right? Because the absolute value has to worry about the x inside. Is it positive or negative? You don't know, so there are always two cases. If it's positive, this is the equation you should work with. If it's negative, that's the equation you should work with. But we always try to solve it so that we have a solution for all possible cases, right? We use this to our advantage. So what I did, I called this equation 1 and this equation 2. We will write equations in form 1 as 2 in order to solve it. Okay, let's get into this. Example. If I told you absolute value of 2x minus 4 is equal to 2, how do you solve for x? I have some more examples, but let's do this first. How about this first one? What do we do?
It can be 2x minus 4 equal to, or minus bracket 2x minus 4 equal to.
Right, and notice here, brackets, or, you know, as the Americans say, parentheses. That was very important because you just took the negative of something. You need to open brackets afterwards because it'll change all the signs. Okay, so if we start with this, because we see that's an absolute value, there are two cases to worry about. Maybe the inside is positive, and that's the equation, or maybe the inside is negative, so we need to take the negative of it to make it positive, right? There are two cases we have to consider here. So now if I solve for that x, here, how would I solve for the x?
Plus 4 on both sides.
You add 4 to both sides, right? So you have 2x plus 4.
Equals 6 and divided by 2.
And you divide both sides by 2. Get x equals 3. What about here?
Negative 2x.
Minus 2x plus 4.
Minus 2x plus 4. And now what?
Minus 2x equal 6.
You'd have to
minus
subtract 4 on both sides, right? Because now it's a plus. To move it over, you have to subtract. So over here, it's 2 minus 4.
minus
And now,
x.
divide both sides by negative 2. So you get x equals 1. Right? So x equals 1 or x equals 3 is the solution to this equation, right? And you can check, you should always check your answers in fact. It's a very good habit to get into, right? If I plug in 1 into this equation, is it true? Well, I would get 2 times 1 minus 4 in absolute values, right? To plug in x equals 1. 2 minus 4 is minus 2. What does the absolute value do with that minus 2? Turns it into positive 2. Which is, yeah, that's what we're supposed to get. So that checks out. What if I check 3? This is 2 times 3 minus 4 in absolute values. That is just 6 minus 4 in absolute values. That is just 2 in absolute values, but absolute value of 2 is just 2. And that also works. Right? So both of these are solutions. Yes?
Can you like combine both equations so you don't do different equations? Am I explaining myself?
No, you'd have to deal with them separately.
Okay.
Yeah. When we get to inequalities, there will be a way to do two things at once, but not here. If it's an equal sign, you have to consider the two cases separately. It's just how it works. Did you have a question? Any other questions?
Can you make that clear, like what you said when I was
Oh, she wanted to know, why do we have to solve two sets of equations? Is there a way to combine it into one? The short answer is no, unfortunately. You have to consider the two cases separately.
because of the absolute value
Because of the absolute value, yes.
and the sum, the sign.
Yeah, the sign in the middle doesn't really matter. Because there are absolute values here, remember there are two cases. It can either give you what's inside or the negative of what's inside. There are two possible values that this can give you, and you have to consider both cases. How about this one?
3x plus 5 equal 8.
All right, so the first thing he's going to do is he wants to move that over there. Do I still have it? Yeah, because he knows he wants to write it like this so that it can go to this one, right? So having that minus 8 over there is sort of annoying. Just move it to the other side. And now what?
3x plus 5 equal 8 or minus all of this.
Right, and we solve these one at a time. So I can subtract 5 from both sides. That gives me 3x equals 3, and so x equals 1. Right? Here I can distribute the negative, add 5 to both sides, right? Which would give me, what, 13? And then I would divide by 3, by negative 3. And so I check my answer here. Right? Plug in 1 for x. I would get 3 times 1 plus 5. That is actually absolute value of 8, which is 8, which is what it's supposed to be. So that one checks out. If I plug in minus 13 over 3, so I have 3 times minus 13 over 3
Cancel
plus 5. 3's would cancel because there's multiplication.
negative 8.
So I have minus 13 plus 5. This gives me the absolute value of minus 8, which is just 8. So that checks out. So both of these answers work. And we consider that to be the solution. Another kind of question you can be faced with is to find the zeros of a function. They might call them roots, they might call them zeros, it's the same thing. But basically that's just a fancy word that says you want all the values where the function is 0, right? So you really want the x-intercepts, basically. So, knowing that, how do we go about this? What equation do we have to set up? Yeah, but we need an equation first. What do we want to solve?
X.
Y equals
Finding the roots of a function means you want to find what?
Zeros.
Finding the x value.
Exactly, so that what happens? Well, the hints already gave it away here. You want f of x to be 0. The equation you have to solve is you replace this with 0.
F of 0.
So that's just 0. Not f of 0. You want f of x to equal 0. It's a different thing. Right? F of 0 means you would plug in x equals 0, which would actually give you 27. It's different from saying that f itself is 0. Right? So this is the equation you have to solve. Right? When you're finding the roots, it means you want the function to be 0, and you need to find the x values that make this happen. Right? How do we go about this? Yeah?
3x minus 27 equals 0. And negative parentheses 3x minus 27 equals 0.
Okay. What do you notice here? Do you have to solve both of these now? Huh?
I'm not sure, like, the second one?
It's 0 on this side. What does that mean?
Wait, what was your question?
Do you have to solve these two equations now?
They're the same?
They're the same,
They're the
right?
same.
No, they're actually the same equation, right? If I divide by -1, I would still get 0, right?
Yeah.
Negative of 0 is still 0, right? So I really only technically have one case to worry about here. Just worry about this equation. How do I solve that equation?
Plus 27.
You can add 27 to both sides.
Then divided by 3.
Then you divide by 3.
X is positive negative 3.
Right, so x would be plus or minus the square root of 9, which is plus or minus 3. And you can check this, whether you put in, this is squared, so whether you put in a positive or a negative, you'd still get positive 9. Positive 9 times 3 will give you 27, minus 27 will give you 0. So these are the values that make that work. How about another one? Find the zeros. F of x equals, let's see. Can you get rid of this? You guys have this. Try those. Start working on this. We'll get to it soon. Did anyone finish this one? So again, I give you a function, I ask you to find the zeros. What do we do?
Equals 0.
Set the function equal to 0. We want 0 to be x squared minus 9 minus 3. Now, how do I solve that equation?
Put the negative 3 on the
Huh?
Put the minus 3 on the other side.
Move the 3 over, so it's in a nice form. Now,
Remove the for the first one, just remove the absolute value sign. Plus 9.
Add the sign.
okay. So if I add 9, what do I get? I get 12.
Then divide by 3.
Divide by 3.
Positive, negative 2.
So x equals plus or minus 2. Is that it? We're done?
Yeah.
No, we're not done.
Check it.
Well, for the minus, for the other equation.
Right, you have to do another one, right? You don't have 0 on this side anymore, so the positive and negative actually will matter in this case. So you have to do 2 cases here. So the last time we only did once because there was a 0 on this side. You have to be careful, right? That's because positive or negative 0 is the same thing, but positive or negative 3 is not the same thing. So you have to do both cases separately. So here, you can move the minus over. This is just minus 3 equals 3x squared minus 9. You can add 9 to both sides. So this would give us 6 equals 3x squared. And then I can divide by 3 on both sides. And this would mean x equals what?
Radical 2.
Radical 2 plus or minus, right? So this one actually has 4 solutions. Right? And if you check these, they'll work out. Right? So you should always do a quick check.
Well, you forgot to distribute the minus.
Huh? No, I didn't I moved it over. I divided both sides by minus 1.
Oh.
That's also valid. Yeah.
You can negative 3 and 6, no?
See, this was the original equation. There was a minus here. I just divided both sides by minus 1. I moved the negative over.
This cannot be.
Alright, so I can actually divide both sides by minus 1. Negative will cancel negative. This will give us minus 3. I guess the knee-jerk reaction of most people would be to distribute. You could do that, you get the same thing. Like if I had 3 equals minus 3x squared minus 9, what you could have done was distribute this. So this would give you minus 3x squared plus 9. Then you subtract 9 from both sides, you get minus 6 equals minus 3x squared. Then divide both sides by negative 3, and you'd still end up here with x squared equals 2. So then your x would be plus or minus radical 2. I just did a different approach. There's usually several ways to skin a cat in math. I found it easier to just move the negative sign over here than distribute it, but if you prefer it this way, that's also fine. Here's a fancy one. How do we do with this guy?
X plus 1 equals to 3x plus 5.
So we just forget the absolute values, just it doesn't matter.
Yeah, that's it.
So there's only this one case to worry about, is what you're telling me.
Then the other equation. Or negative minus x minus 1 minus 3x minus 1.
Well, if I put a minus here, this actually gives me the same equation. It turns out there are going to be 4 cases here, but you only have to consider 2, right? You can consider both of the insides are positive, which absolute value will make no difference. But what if this one is negative and that one is positive? You'll get this, right?
Or the other one.
If this one's negative or that one's positive, you'll get an equivalent to this because you can move the negative sign over. If both are negative, then you still get back to this, right? In all 4 cases, you'll get back to one of these two. So if you have something like absolute value x equals absolute value y, it actually means that x equals plus or minus y. You only need to consider 2 cases. Technically there are 4, but they'll all be equivalent to one of these two.
Yeah.
So
Because if you move the signs around, you'll realize, oh, I keep getting back these 2 equations that I am.
So it just end up to 2.
Yeah. So it ends up with 2. You end up with 2 cases. Right?
it's not necessary to write 4 different. I mean,
Yeah, because the absolute value can change the sign for each pair. Right? So you can end up with this, where both of the insides are positive. If this side is negative, you'll end up with that. If the other side is negative, you'll end up with this. Or if both sides are negative, you'll end up with this. The thing is, this equation is the same as that. And this equation is the same as that. So these you don't even have to worry about. So we only have 2 cases to consider. Another way you can think about it, I'm going to write out the full solution soon, but I just want to tell you all the ways you can think about it. So one way to think about it is just take the plus or minus of one side and you're good. Another way, you can actually move this over here. So you can actually have x plus 1 divided by 3x minus 5 equals 1. And then this guy, the absolute value can distribute across a division. And then you can do the 2 cases from here. Right? So either way you think about it, you'll get to the same idea. The thing about division is I want you to be careful. Well, you'll see it over there actually. You might be dividing by something that could be 0, which would be bad. Right? Remember, we always want to stay away from 0. So the division, you always have to be careful. You have to make sure that x equals 5 over 3 is not a solution before you actually do this. Right? Because if x equals 5 over 3, the denominator is 0, and then you messed up. But fortunately, if x equals 5 over 3, this equation is not true. So division is actually allowed here. So now that we said that, I'll just go through and summarize. You have absolute values on 2 sides at the same time. You just apply the plus or minus to one side, and you'll be fine. It'll cover all the cases. Right? So you have x plus 1 equals 3x minus 5, or x plus 1 equals minus 3x minus 5. So we can solve, move the x over here, I get 2x. Move 5 over here, I get 6. This means x equals 3. Huh? Here, I would distribute the negative sign. This is minus 3x plus 5. Can bring the minus 3x over here. That will give me 4x.
Equals 4.
Move the plus 1 over there. I would get 4.
X equals 4.
So x equals 1. And you can check. Plug in here, x equals 3. 3 plus 1 is just actually value 4, which is 4. Over here, if I let x equals 3, this is 3 times 3 minus 5. That's 9 minus 5, which is 4, which is 4. So that checks. I can also check x equals 1, plug it in here. 1 plus 1, that's actually value of 2, which is 2. If I plug in 1 here, I get 3 times 1 minus 5. That's absolute value of minus 2, which is still 2. So both of these check.
Sorry to interrupt you. Can you say again how do you use plus or minus there? I'm not getting there.
Right, so remember that if you take absolute value of x plus 1, you could have x plus 1 or minus x plus 1, right? We had that before. We had the rule that says if you have absolute value of x equals p, then either x equals p or minus x equals p. Remember that? That was the first rule we had. Right. The thing is here we have two absolute values to worry about, so they can switch signs at any time. So then we worried about what are all the possibilities, right? So this can be plus or minus, and at the same time that can be plus or minus. It turns out that there are 4 possibilities, but they all reduce to 2 possibilities because the equations are equivalent. So if I had x plus 1 equals 3x minus 5, then there are 4 cases, right? What if both the insides are positive? Possible? Then the absolute values won't make any difference, right? You can just neglect them. But what if the inside, this is negative and that's positive? Then that would give you another case, which is this. What if vice versa? This is negative, but that's positive. Then that gives you another case. X plus 1 equals minus 3x minus 5. What if both the insides are negative? Then that gives you another case.
So you can use either way and it's going to give you the same
Yeah,
answer if you use any of those forms?
Yes, but it turns out that there is some redundancy here. Because this equation is exactly the same as this equation. Right? I can just divide both sides by -1, and I get here. So these are actually the same equation. And this equation, it turns out to be the same as that equation. Right? Because if I divide both sides by -1, I get here. So really the thing is, I only have to care about 2 of them, which is what I did here.
So in that case, it's your choice.
Yeah.
Whatever you want to use, right?
Yeah. Just make sure what you solve covers all possibilities. And according to this, if you solve these 2, you solve everyone, because the other 2 are the same. So once you have both absolute value signs, just leave one alone and put plus or minus on the other side. You'll get everyone. What's that? Okay, what about this one? Well, like I told you, absolute value sign distributes across divisions. So I can think of it like that. Which gives me 2 cases. This equals 1, or this equals minus 1. Let's worry about the first one. How do I solve this?
multiply by 1.
Right? You can take this and move it to the other side. Just multiply both sides by 1. Or some people like to think of the cross multiplication. Right? 1 over 1 you cross multiply. So this gives you x over 2 minus a half equals 3 minus 3x. And now what?
Multiply everything by 2.
Right, he doesn't like the halves, so what he's going to do is he's going to multiply through by 2 to kill the halves, right? So take this entire equation, multiply by 2. And so this is going to just be x.
Minus 1.
This is going to be 1.
6 minus
This is going to be 6. This is going to be 6. And so now I can move this minus 6x over here. I would get 7x. Move this minus 1 over here. I get 7. So x equals 1. Right. And I can do a similar thing here. I would get x over 2 minus a half equals minus 3 minus 3x. So I can take x over 2 minus a half equals minus 3 plus 3x. And again, if you don't like fractions, it's okay. You can get rid of them. Just multiply both sides by 2. It's an equation, so we can do this. 2 distributes. This is x minus 1 equals minus 6 plus 6x. Move this over. We'll move the x over here. I would get 5x. Move this over there. I would get 5. So this again gives me x equals 1. And is that the answer?
Yeah, 0 equals 0.
Well, check in the original. Right? If I plug in 1 into the original, what would I get? A half minus a half divided by 3 minus 3 times 1. Right?
Yeah.
What happens?
0 divided by 2.
I get 0 in the denominator. Right? So this equation actually has no solution.
Why?
If I plug in 1 into the original, there's a 0 in the denominator, right? If I plug in x equals 1, I get 3 minus 3. 3 minus 3 is 0. I divide by 0. We never divide by 0, even if we have a gun to our heads. So the only possible solution is a solution that causes us to divide by 0, means there's no solution. There's actually no x value that will make this work. There's nothing you can plug in here to get 1.
But it can be equal plus infinity.
No, it won't be.
Plus
It won't be
zero
anything.
is,
Won't be anything. When you get to calculus and talk about limits, then you can say the limit would be 1, but let's not talk about that. That's 2 semesters away. Okay. Write the functions without absolute value signs. How do you think we do it? Well, let me do the first one and then you can see the second one. So remember, if I have absolute value 3x plus 1, right? What is that equal to according to the definition? What are the possibilities here?
3x plus 1.
It will give me 3x plus 1 is one possible value. When do I get that value?
X is greater than 0.
No. Let us remind ourselves of the definition. suggested here. Now, do you see what to do?
So 3x plus 1.
So it will give me 3x plus 1 in what case?
3x plus 1 is greater than or equal to 0.
If 3x plus 1 is greater than or equal to 0. Or
minus 3x
3x
minus 1
if 3x plus 1 is
is
less than
0.
0. Right, so if 3x plus 1 is greater than or equal to 0, what does that tell me about x?
It's positive.
No? Tell me the range where it will work. Solve the inequality for x. You remember how to do that? You can sort of treat them like equal signs, right? You can subtract 1 and divide by 3. This just means your x has to be greater than or equal to minus a third. Right? This says your x has to be less than minus a third. So in other words, my f of x, I can rewrite it as a piecewise function. It's either 3x plus 1 if your x is greater than or equal to minus 1/3, or it's minus 3x plus 1 if your x is less than minus 1/3. At this point, you can sort of appreciate why I don't really like how the syllabus is organized. If I was doing algebra, I'd teach about equations and inequalities first, and then when we get to here, it would be easy. Because now we have to deal with an inequality, but you probably don't even remember what an inequality is. So we actually do that later. I think the order is sort of weird how we do it, but whatever. We'll do a lot more practice with inequalities in the coming future.
So 3x minus 27.
So this would give us 3x squared minus 27 in what case?
X is greater than or equal to 3. Positive, negative.
X.
You need 3x squared minus 27 is greater than or equal to 0. Right? The whole thing.
Yeah.
Or it's the negative if 3x squared minus 27 is less than 0. And I can't really get around this without actually talking about inequalities, so I'll probably just give you the answer. This will be plus or minus 3, so it's positive if x is greater than or equal to 3, or x is less than or equal to minus 3. And this says your x has to be between minus 3 and 3. The reason being is the following. Can I erase this one? Can I erase here? This. Before talking to you about inequalities, because our syllabus is crazy. The easiest way probably is if you remember how to graph things. The graph of that would look like this. The intercepts would be at minus 3 and 3. And realize It's positive if you're bigger than 3 or less than minus 3, which is why I have this. And it's negative when you're in between them. But there are other ways you can test for this, and again, we do that later in the syllabus. So for now, you can sort of take this on faith. We'll do a lot more practice with this. Maybe I'll tell you, because in my notes I sort of talked about it, because I realized that we did inequalities and we never really spoke about it. So let's deal with some inequalities now. This actually completes 3.3. That's everything you need to know. We're going to move on to 3.5, where they talk about absolute value. The chapter is on, this whole section is on inequalities, but we're only focusing on the absolute value inequalities. So at least here, I started from scratch, even though in the text you do an earlier chapter, but it's not in our syllabus, so I actually started from scratch. What I need to tell you about absolute inequalities. Or called inequalities. Do you remember what this is called? This is greater than. This is greater than or equal to. This is less than. And this is less than or equal to. That's sort of how you think about it. So you use these when things aren't exactly equal. One can be less than the other. So for example, if I say x is greater than 1, this means, x is greater than 1. Meaning at this point, I'm not sure what value it is, or I know it can be any value bigger than 1. As long as you take anything bigger than 1, it will satisfy this inequality, right? We could write, in general, if you just flip an inequality around as is, it doesn't change. So if I wrote this, just took the mirror image, it actually means the same thing. This means 1 is less than x, which is actually equivalent to saying x is bigger than 1, right? Saying x is bigger than 1 is saying 1 is the same as saying 1 is less than x, right? So they both sort of mean the same thing. So inequalities you can flip around. I wrote that, so. And also remind you of the basics of solving them. I put it in my notes here. To solve an inequality. Treat it as an equal sum. There are two caveats to this, so I'm going to mention those. And solve as an equation. We'll talk more about what that means. The two caveats are the following. When you treat things differently. Okay. So I said overall, when you're solving an inequality, you can treat it like an equal sign. There are two times when you can't, right? There's one case if you multiply or divide. There's something if you multiply or divide by, it will change things. Anyone knows? Negative numbers. If you multiply or divide by a negative number, you must flip the inequality sign. You must flip the inequality. So, for example, right, so overall you can treat it like an equal sign, except in one of two cases. This is one of the cases. So for example, if I say 2 is bigger than 1, which is true, if I multiply both sides by 1, my negative 1, then this would be minus 2, that's how to be minus 1. I will have to actually turn this around, right? Right? Just by multiplying by a negative means this sign here, it was this way, I have to turn it around that way, right? Once I multiply or divide by a negative, this has to be true, right? And if you draw these on a number line, you'll see, yeah, it's minus 2 is actually less than minus 1. Right? So if you multiply through by a negative, you have to turn the sign around, right? That's one way it's different from an equal sign. Another way, there's a second way it's different from an equal sign, and it sort of has two cases. If both sides have the same sign, then you must flip the inequality. If you take the reciprocal of both sides. So overall, you can treat them like a negative, like an equal signs, except if you multiply or divide by a negative number, you have to turn them around. Another case you have to turn them around is this case. If you take the reciprocal and both sides are the same sign, you have to turn it around. For example, 3 is greater than 2, right? You know what reciprocal means? Upside down, you put 1 over, right?
So
This means 1 over 3 and 1 over 2, how do those relate? You actually have to turn it around. Right? If I flip both sides, they're the same sign, I have to turn the sign around. Okay. So. I want to highlight that I'm turning the signs around. So once I flip both sides, if they're the same sign, I turn the sign around. If they're not the same sign though, I shouldn't do anything. For example, 3 is also bigger than minus 2, correct? But if I flip both signs, this is still greater than that, right? Because this is still negative and that's positive, right? So that's something you have to worry about. If they have the same sign, they're both positive on both sides, and if you flip, you have to change. But if they're different signs, then keep it the same, right? A positive will always be bigger than a negative, right? No matter what. So, other than those two things, you can essentially treat them as equal signs when you're solving an inequality. So technically this isn't in our syllabus, but I figured I should do some regular inequalities first, and then we talk about absolute value ones. Just to do a couple of examples. Example. Yeah.
When you say do not flip the last part.
Yeah, notice here I didn't change the direction.
Okay, so you keep it the
I
same.
kept it the same.
But
Because the signs were different. This was a plus, that was a minus.
why turn into a fraction?
There might be cases where I want to flip.
Oh, you flipped it into reciprocal.
I want to take reciprocal, right? So that would be like in a case if I had like 1 over x is greater than something. To solve for x, I'd want to flip both sides. But I just want to show you if you flip, you have to turn the sign around, provided the signs are the same, right? You might need to flip for whatever reason. Let's see. So, another example. X squared minus 1 greater than 0. And I'm going to show you what it means to test the intervals to know you're correct. Example. Very similar, but there's a point I want to make here. When we get to absolute value equations, it's going to come. You're going to see why I did. So let's say you're given this inequality, you want to solve for x. How do you do it?
Plus 4x.
Right. Essentially, think of this as an equal sign. The only time you don't think of it as an equal sign is if you're doing one of those two operations, right? So yeah, you bring the x's to one side, so you'd add 4x to both sides. So you'd have 4x plus 2x is 6x. And then I'd subtract 3 from both sides, right? So that would give me 12. Now what? How do I get to x? I can divide both sides by 6. Now 6 is a positive number, so I don't change the sign. It just stays the same. So x is greater than 2. I usually don't write intermediate stages, so notice that this is what's happening. I added 4 to both sides, and then subtracted 3 from both sides. I know some people write it down, but sort of want to discourage that, so I might skip it sometimes. Yeah?
It can be x greater than 2 or x less than 2.
No, it has to be greater than 2 for this to work.
So we have only one option.
In this case, there's only one option, yes. In absolute value cases, there are several. We'll get to that. So if x is greater than 2, then this will be greater than that. And you can even check it. Plug in something less than 2, and you'll see that this doesn't work. Plug in x equals 0, right? This side will give you 3. That side will give you 15. 3 is not greater than 15, right? So it's not true. It will not be true if your x is less than 2, right? Any number less than 2 will not work. So you have to be bigger than 2. One other thing that I need to tell you about interval notation. Is anyone familiar with that? Let's write things as interval notation. Do you know what that is? Could you graph this on a number line?
Oh.
If you graph this on a number line, right? You know, to the far left there's negative infinity, to the far right there's positive infinity, right? There's a 2 here.
You graph it down.
Also,
And then you write an open circle here, right? And then move it.
When you talk close it is when it's equal to.
If it can be equal to, you'd shade that in, right? Now the interval notation sort of goes from this to something that you put in parentheses. Right? You'd write 2 to infinity. Has anyone ever done that?
Yeah.
Right, this is saying you're going from 2 all the way up to infinity. Everything greater than 2 can work, right? So you would write this. And because there's an open circle here, you would put parentheses, right? Someone asked me the first day, what's the difference between brackets and parentheses? In interval notation is one place where it actually matters whether you put a square thing or a round thing. Here, when there's an open circle,
It's not
it has to
equal
be
to-
round. You can't be equal to. There are going to be cases where you have to write a square bracket here, which means you shade in the circle. So you might see answers represented in either way. This is called the inequality way notation. This is called interval notation. Now this one's a little bit more tricky. But how would you solve that? How would you guess to solve this?
N plus 1.
Yeah, think of it as an equal sign. You can add 1 to both sides.
Usually x. X greater than plus or minus.
So x is greater than 1.
It's gonna be blue.
Yeah, so the thing is here, you sort of get x's plus or minus 1. The thing is, how do you know if it's greater than or equal to, or is it greater than both of them? Or less than both of them? You know, you don't know. So this is where testing the interval comes into play. So what you do is, again, you do your whole number line thing. Right, there's your infinity, minus infinity. And there are 2 values you worry about. You're not sure there's a minus 1 and there's a plus 1. You know you can't be equal to either of them, but which interval will work? Well, all you have to do is test numbers, right? So you plug in a number in between these. So for example, you pick any random number in over here, like minus 2, right? If I plug in x equals minus 2, is this true?
Yeah.
Plug in minus 2, 2 squared is 4, minus 1, I get 3. That is greater than 0. So yeah, this side works. Right? What if I plugged in a number in between these two, right? So like, what if I plugged in 0? Would it work?
No.
Plug in 0 for x. Minus 1 is greater than 0. No, that's not true. So the middle does not work. What about if I plug in another value, something bigger than 1 on this side? 2, would that work?
Yeah.
Plug in 2 here, 2 squared is 4, minus 1, that's 3, which is greater than 0. So this side also works. So now, if I ask you the solution in interval notation, how would you write the solution?
So parentheses,
It's gonna be
negative infinity,
Everything from negative infinity all the way up to
negative 1.
negative 1, but not including 1.
Yeah.
Right? Yeah, then?
Then 1, parentheses 1, then positive infinity.
And then we can be anything from 1 up to positive infinity. Now the notation is, when both of these can work, you write a u in between them. This means union. Right? So that would be the solution. That's how you write this. Or you can say x is less than minus 1, or x is greater than 1. Right? So if you look back at the example I did with that, finding this, rewriting the functions, and I did that whole thing over there where x can be less than negative 3 or greater than 3, this was what I did in my head to give you that answer. So there are actually 2 options here, right? The solution is expressed as 2 inequalities, or in interval notation, it will be this with a u in between. You always put a u. Okay. What about this one? It's very similar. So again, here you'd sort of get plus or minus 1, and here again, to figure out where the inequalities happen, because there are several values that are possible, you would do this again. Now the thing is though, this can be equal to, right? So you'd shade the circles. And now you just, these 2 numbers split the whole number line into 3 parts. There's the part over here, the part in between, the part over here. You test any random number. So you test minus 2, you can test 0, you can test 2. If I plug in minus 2 into here, does it work?
4.
I would get 4 minus 1, which is positive 3. Is positive 3 less than or equal to 0?
No, it's
No.
not possible.
No, so this doesn't work. Or if I plug in 0, 0 minus 1 is minus 1. Is that less than or equal to 0? That does work. So in the middle works this time. Or if I plug in 2,
No.
doesn't work, right? Plug in 2, I get 4 minus 1, which is 3, and that's not less than or equal to 0. So in this case, the only numbers that work are between minus 1 and 1.
So
Right.
bracket.
Here's where you use the bracket, right? I use the square brackets to say minus 1 is included.
It's close.
All right. These are called the closed brackets. These are called open brackets. Yes, that's good. Right? Or you can basically write x is less than or equal to minus 1 or 1. So you can write this inequality notation. This is called interval notation. There was a point to these two examples. Can you sort of tell me the relationship between these two? What do you notice about them? Do they have anything to do with each other at all?
Yeah.
If you had to describe the relationship, how would you describe it? This versus that. Just say what you think, even if it sounds obvious. You'd be surprised.
Indirect relationship.
You're what?
Indirect relationship.
What do you mean indirect relation? Describe what you mean.
I'm thinking of the term too.
Don't think a term. Explain in a word, a sentence or something. Like what do you notice?
Oh, if those work, that's not gonna work. If the middle works, the other sides are not gonna work.
Right. You can sort of think of them as opposite, right?
Yeah.
Everything that's missing here is over there. Everything that's missing over there is over here, right? Less than is the opposite of being, greater than is the opposite of being less than or equal to. That's sort of what I want to get at, right? And that's actually going to make our lives easier when we get to absolute value equations. Right? So the book is going to tell you, oh, you can split this into two cases, but there's a way you can do it where there's only deal with one case, but you think of it as in terms of opposites. Right? So this was one thing I wanted to show you. Right? If I put greater than or equal to, then less than would be the opposite, and so on and so forth. So that's just one thing I wanted to show you. So. How about let's solve a couple more. X squared plus x greater than or equal to 6. X plus t greater than x squared. for these, you're going to have to remember how to solve quadratic equations. All right, let's work on these together. I want to finish this section. You can turn the camera. Okay, what did you try? Did anyone try it? Yeah, what did you try?
I did do x squared greater than 6 minus x.
You put
I
x
just
squared
put x in.
greater than 6 minus x. And then what did you do with that? Huh? Yeah?
I think that and then for the x is greater than square root of 6 minus x. So it should be less than or equal to 5 because you can do square root of 0.
No.
We do x squared plus x minus 6.
You put minus 6, right? I don't know if you did quadratic equations in your last class, but when you have a quadratic, the thing is everything should be on one side, 0 on the other side. Right? You'd never leave non-zero terms on one side. The first step would be to do this. And once that's done, what would you do? Well, you check if you can factor, right? If you can't factor, use quadratic formula or completing the square, right? But
X
this does factor.
x plus 3
Minus 3.
times x minus 2.
Right, now this gives you two options. Either your x is minus 3 or your x is 2, right? So here's where we stop thinking of it as an equal sign, right? Before, if this was an equal sign, that would have been our answer, but it's not an equal sign, so now we have to make sure that this actually works in our inequality, right? So we have to worry about minus 3 or 2. We can be equal to, so I'll fill in these circles. And now I just want to test numbers. So I can test like minus 4, I can test zeros between this, right? Pick an easy number, it doesn't matter what number you pick, so pick nice ones. You can test 3. So if I plug this into that, right, if I take, 4 plus 3 times 4 minus 2, Is that greater than or equal to 0? All right, plug in 4 here.
Yeah.
That's positive. Plug in 4 here. That's still positive. So yes, that does work. This works over here. So all of this works. What if I plug in 0? Right? This means I go here, plug in 0 for x. I have 0 plus 3 times 0 minus 2.
Minus 6.
This is greater than 0. This would be
Minus
negative, right?
Yeah.
Because it's a positive times a negative. You don't even care about the number. You only care about the sign. Plug in 0 here, this will be positive. Plug in 0 here, this will be negative. Positive times negative is negative, so this does not work. Plug in 3 here, positive. 3 here, positive. It works. So what is the answer here?
Open bracket, negative infinity, the negative 3 bracket, then bracket 2, positive infinity, open bracket.
And then you. Okay, this one. It's a quadratic, so you're going to do the same thing. You bring everyone to one side.
X minus 2.
X squared minus x minus 2 would be less than 2. Right? I bring these to that side. What do we do now?
X
X
minus 2
minus 2.
times x plus 1.
So from this I would get x equals 2. From this I would get x equals minus 1. Put that on the number line, minus 1 and 2. It's a strict inequality, so these are unshaded. And then I'm going to test numbers, like minus 2. I can test 0. I can test 3. So if I plug in a negative 2 here, that's negative. This would be negative. Negative times negative is positive. So this does not work because I want to be less than 0. Plug in a 0, negative times positive, which is negative. So this works in between. Plug in a 3. This is positive. This is positive. Positive times positive is positive, but I want to be negative, so that doesn't work. So the final answer is what here?
Open bracket, negative 1, 2, open bracket.
Can you go over that? Because I did not understand. I got lost.
Which part? Did you get lost here? I just bring everything to one
Oh,
side.
not that part. After.
Okay, do you remember how to factor?
Yeah.
Okay, so after that, you would be able to get these two answers, right? Because you set each equal to 0. Right? So x minus 2, you set that equal to 0, you get x equals 2. Or x plus 1 equal to 0, you get x equals minus 1.
Wait, but when you minus, because you're trying to make it a quadratic equation, right?
Yeah,
So when you minus x squared, it comes on the other side.
I didn't minus x squared.
Well,
I subtracted these, I moved these to that side.
Oh,
I want to keep my square positive.
oh,
So he's positive over here, I don't want to move him. I move the others to that side.
all right, now
Yeah. What I did was I subtracted x and 2. And then I actually got 0 is bigger than x squared minus x minus 2, but then I just wrote it in this side. I just flipped it. As we said, that these mean the same thing. So now we know about inequalities. Let's actually talk about how absolute values affect these guys. I'm just going to write down a couple of rules. Your book actually covers them in chapter 1, but it's not in your syllabus. It comes straight from the definition though, so of absolute values. So we'll just take this on faith for now and move on. If you have the textbook and you're interested, it's in section 1C. We have rules for absolute value equations, absolute value inequalities. They break them into two types. There's a type 1, and this means you have things like x is less than p, or x less than or equal to p. Right? So basically you have something in absolute values less than something else, and of course here your p has to be strictly positive, because otherwise it wouldn't work. Well, it can also be 0 here. There's also the type 2, where your x is greater than p, or x is greater than or equal to. And we are going to learn how to solve this. These ones are okay. You get like one inequality with two inequality signs. These ones, though, you have to split into two. But based on a previous example that I gave you, you could actually think of this as the opposite of that, and this as the opposite of that. And so solving these are easier. You can actually use their solution to help you with these. So, but we'll get to that first. We'll get to that in a bit. And I'll show you, and you can see if you like that more or less. Let's break it into type 1 examples. So I have these examples. Absolute value 2x minus 5 is less than 3. I didn't actually explain what you should do. Let me write that down. Whenever you see this, you can actually split it into this. And whenever you see this, similarly, you can split this into that. All right, so it's a rule they derived back in chapter 1, part C. This would mean two things though. This you'd have to break up into two inequalities, either this or this. So this is x greater than or equal to p, or x less than or equal to minus p. I'm going to show you how these two cases work with these examples. Let's focus on the type 1s for now, and then we'll move on to type 2s. Those are our type 1 examples. So our,
Question.
yes.
Why you broke it down like that?
It comes from the definition of the absolute value. Remember, this can be positive x or negative x, right? So if it's a positive x, then you just have x less than p. You just drop it, which gives you this part. If it's negative x, you have minus x less than p, but then you divide both sides by a negative, you switch the sign around, and you get this part. So, but for now, we're just taking this as rule. These are derived from the definition of absolute values. So, if you're given this, what do? Once it's less than, you can break this into one big inequality with the number up here and it's negative down there. That'll always be true. And now what happens is you solve it just like you would pretend these are two equal signs, but you're doing things on all sides at the same time. So you literally add 5 everywhere. So I want to solve for the x, so I'll add 5 in the middle, but I'd have to add it to both ends as well. So I do that, and I would get 2x. This side will give me 8. This side will give me 2. Right. And then to solve. Yes. Do you have a question?
I don't know what you say. It's x time.
X time?
I mean 8 times 2. Over 2.
Yeah, we want to solve for x.
Yeah.
So I would divide by 2 to get x by itself. But I have to do it everywhere, right? And inequality is just like an equal sign, so you have to do it on all sides, right? So at this point now you get 1 less than x less than 4. So that's your solution. Your x has to be between 1 and 4. Or in interval notation, parentheses 1, 4, close parentheses. All right, so as long as your x is between 1 and 4, this will be true.
Did you minus 3?
Here,
Get that?
yeah, when you see absolute value as less than, you can split it into 2, where the positive 3 over here, and you just put a negative 3 over here. All right, what do we do here?
-4 less than.
That's always the rule. Absolute value less than something, you split it on both sides, and negative goes on the far left. And now what would we do?
Minus 7.
You're right, you subtract 7 everywhere. So this would give you minus 11 less than equal to 8 less than equal to minus 3. Then to solve for 8, I would divide by 3 everywhere. And so that would give us minus 11 over 3 less than equal to 8 less than equal to minus 1. That would be the solution. Or in interval notation. Any questions on this? Okay, ideas for this example.
Move the 8.
Move the 8, right? We want to get it in that form, in a type 1 form. So I first add 8 to both sides. 3x plus 5 less than, you add 8, so you get 13.
You do minus 13
And so it's minus 13,
less than.
3x plus 5 less than 13.
Minus 5.
Right, so now I subtract 5 from everywhere. So this would be minus 18.
3.
Then you divide both sides by 3. So 3 into 18, 6 times. So that's your solution. Your x has to be between -6 and 8/3. Or in interval notation, -6, comma, 8/3. Type 2 examples. The type 2 ones are a little bit harder, but I can show you. Yeah.
Did you add -8 and 5?
We're talking about here? I added 8 to both sides. +8, +8. So I get it in this form, which tells me I can split it.
So you did that just to cancel out -8?
Yeah. By the way, this is just to point out something I mentioned on the first day. Remember that I said, you know, you get pretty much far. All the math you need to know for engineering, at least, it's all about forms and algorithms. It's all about, basically, I give you a rule, it's telling you a form that you want to get to in order to solve it. Anything that doesn't look like this, you have to make it look like this before you can do anything, right? So notice that in our form, on the left side, I didn't have something being subtracted or added. So if I have something here being subtracted or added, I don't want it, move it, right? You need to get it in the right form, right? Form and algorithm, that's all it's about. So once I added 8 to both sides, I got it into the right form where I could apply that rule. And then I applied the rule. And from here on, I go through the algorithm of solving the inequality. So that's another thing to talk about, you know, some general tips on being good at math and what it takes. Okay. All right, let's deal with this one. So here, this is what we call a type 2. Now, type 2s will actually split your thing into 2 separate inequalities. You can't do it all in one like we did here, if there's a greater than sign. Right? If you apply the definition of absolute values, you'll see that you would have to deal with these 2 separately. Right? It's sort of like these one gets you in the middle, but these greater than gets you on the outer edges. Right? So you have to split them. So we have our first example, 3y plus 9 is greater than or equal to 6. Yeah. So it turns out this guy, according to this type 2 rule, you'd have to split it into 2 parts. Either the inside is positive, and you can leave it as 3y plus 9 is greater than or equal to 6. Or the inside could be negative,
3y.
and so you have 3y plus 9
Is less than
less than or equal to minus 6. And so now we solve these one at a time. I can subtract 9 from both sides. That gives me 3y greater than or equal to minus 3. Then divide by 3 on both sides. This gives me y is greater than or equal to minus 1. Or, again here, subtract 9 from both sides. So minus 6 minus 9 is what? Minus 15. You just sort of add them and keep the negative sign on the outside. And then I divide both sides by 3, right? So it's either greater than minus 1 or less than minus 5. And notice that this one actually splits your interval into 2. You're either, here's your -5, here's your -1, but it gives you the outside. It's either less or more, and it leaves off the middle part. It turns out the less than or equal to absolute value signs gives you the middle part, while the greater than gives you the outer part. So having that in mind, I mean, you can always do this, that will give you the answer, but if you don't like doing two inequalities, you can actually do the opposite. So, or, I'm not sure if anyone would recommend doing it this way, or a textbook would say to do it this way, but a lot of times this is how I think about it, so I figured I'd tell you anyway. Notice that this is the opposite of this. Right? What's the opposite of greater than or equal to? Less than. Meaning, if I find this and I can find the interval that works here, just take the opposite interval, it's going to work there, right? Why would I do that? Because with the less thans, it's easier, right? I can just do one thing. I don't have to break it into two parts, right? So this one I can solve. This is just -6 less than 3y plus 9 less than 6. Subtract 9 from both sides, right? I get -15 less than 3y less than -3. Divide both sides by 3. And I get this as the solution, right? Y is strictly between -5 and -1. Well, what would be the opposite to that solution? Unshade this, shade everything else. That would mean opposite solution. That would mean that the solution to this one is just everything other than was the solution to that one. Meaning I would shade these instead of leaving them open and take the outsides instead of taking the insides. Right? So the solution to this one would be strictly between -5 and 1, while the solution to this one would be less than -5 inclusive or greater than -1. So it's just something to think about, another way to do it. Your textbook recommends doing it this way, just split it into both and deal with each part separately. You could also just think of what would the opposite solution be like. That one's a lot easier to do, and then you just shade everything else for what you would do. You have to remember to switch it at the end. It's not going to be the same. To that end, look at the first example we did for type 1 and tell me if you can just tell me the answer without doing any calculations whatsoever. That would be ideal. Example 1 for type 1 was, I gave you 2x minus 5 was less than 3, and the answer for that was, what did we get for the answer?
Open bracket 1.
We got open bracket
1.
1 and 4?
Open bracket.
Okay. So that was the answer for example 1. What do you think the answer for this one is? without doing any calculations, what would you say it is?
So negative infinity.
So the answer here is going to be minus infinity up to
Bracket 1.
1, but include 1 this time. Yeah, what else?
Then bracket 4. Then positive.
And you put a union in between, right? So this is just hammering home that if you know the opposite, you automatically know the other one, right? I know what happens to less than 3, which means I automatically know what happens to greater than or equal to 3, right? It's just whatever wasn't here is over here, right? And if you did this both ways, you'd see that when you go through all the calculations, you'll actually get this as the answer. What about this one? What's the first step?
Add 4.
Add 4, because we want to get into a certain form. We want to get into type 2 form, so adding 4 would be the first step. Now what?
Wait, do we do the type 1 or type 2?
This is type 2, technically. It's greater than.
Okay. Can we change it to type 1?
You prefer doing that?
I don't know.
Whatever you guys prefer. I can do either way. So
So
you can.
6x minus 1 greater than 6. 6x minus 1 less than or equals negative 6.
This is doing the original way that the book recommends. You can just split it in 2. Once it's greater than, you have to split it into 2. And here, add 1 to both sides. Divide both sides by 6. Over here, again, add 1 to both sides. Divide both sides by 6. So that gives us 2 situations here. For interval notation, I have to minus infinity up to minus 5/6. Bracket, because we can be equal to. Union 7/6. Yeah, only when there's it can be equal to, that's when you write a bracket. The bracket sort of means including this. You leave parentheses or open brackets when you say not included. So leave you with a few more examples to try for next time. X plus 4 minus 3 is less than minus 1. Minus 5. 6x minus 1 minus 4. We'll end there, but you can try those for next time.